Digital twin is a virtual replica of your shop floor. It tells you exactly what is going on your shop floor in real time. IcSoft MES helps you to build a foundation for this digital twin. Let us have a look how it does it. Operators work on machines to produce certain parts or products on the shop floor. These operations generate a lot of data which is captured either by IoT or input through various HMI devices. This data could be machine data, it could be production data, it could be quality data. This data is fed to the manufacturing execution system, the digital manufacturing solution of IcSoft, which in turn gives vital inputs which are required for taking various decisions on the shop floor. For example, dynamic schedules, keeping in mind the status of the machine and material, digital work instructions to tell the operator what exactly to do at every step of the manufacturing operation, material requisitions precisely when the schedule uh, asks for the material, maintenance schedules based on preventive maintenance schedules and weaving them into the production plans, quality plans which tell exactly which tests to perform and when during the entire manufacturing process. And last but not the least, machine control, which uh, ensures that whenever there is a deviation from the process or if the results are abnormal, the machine stops automatically rather than depending on an operator. So, in a way, this is a closed loop system, but at the same time, it has got another aspect, which is the digital twin we spoke about. This digital twin gives real time status of various aspects of shop floor operation. For example, it tells us what is the exact status of a production order at any given time, what is the status of the machine, whether it is overloaded, whether it is working to its full capacity, whether it is running idle, whether all the machine parameters, for example, the pressure, temperature, vibrations, whether they are under control. It gives us real time energy consumption at various machines and sections and departments uh, of the shop floor. It tells us about where exactly the shortages are occurring, whether material is available sufficiently to carry out the production. It tells us where exactly the bottlenecks are at any given point in time, where work is getting accumulated, and what can be done to debottleneck those. And finally, the process capability, whether the process is in control or whether the variability is too much, so that we can take early actions before actually the process variability starts creating quality issues. Having this information in real time is of enormous value to any plant manager. Let us have a look at each one of these, how it happens. So, the dynamic schedules. Here we see that a work order has been loaded on one of the machines, machine name is mentioned here, then operator reports a breakdown of that particular machine, and which is a very common day-to-day scenario in any plant. Now this replanning those orders, which are scheduled on that machine, could be a nightmare. But in IcSoft MES, it happens at the click of a button. Here we can see that the order has been now scheduled to another machine. And this is not as simple as it looks. This could be a very complex activity, keeping the availability of various resources, what has been scheduled on those machines, which orders have more priority, which orders have uh, early delivery dates, or which can be postponed. Keeping all these factors in mind, the underlying algorithm of dynamic scheduling automatically reschedules the orders. So, one is capturing real time machine information and using that information to replan instantaneously. You find many IoT services providers who actually give this information in real time in terms of what's happening on a machine or what's happening to an order. But the key here is instantaneous replanning as and when an issue arises. That's real responsive manufacturing. Digital work instructions. Training the operators is a big investment for any manufacturing operation, which affects their productivity. This is also supplemented by paper instructions in most of the factories. A more efficient way of doing that is providing these digitally for the operation which an operator is supposed to perform. So it tells us various steps to be taken and exactly the operation which is on hand. It gives a detailed visual uh, also uh, in order to guide the operator how to perform that particular operation. And it is again not just a work instruction. It also acts as a checklist which expects the operator to tick mark or check those check boxes that particular step has been completed. This does not leave anything to chance and takes care of complete compliance with the process, thus minimizing the errors, minimizing the defects, and improving the labor productivity. Material requisitions. Once a schedule has been made, it gets converted into an issue plan. And then the issue plan guides the stores in terms of which material is needed when. So here we see the requirement details, what is the quantity needed, how much is available in stock, and when is it due, when is it required. So once this plan is in place, the advance action of shifting the material to the required workstations can take place, and this again improves the uptime because the machine is not waiting for material during the changeovers. So these requisitions, actually the way they work is operator identifies the material which is required, which is this one in this case. Once it has been done, once he identifies, the system tells the stores person where that particular material is lying. So, in which aisle or which bin that material is lying. The next step is to go to that place, enter the quantity which is required, and then scan the barcode on that particular material with the help of a handheld scanner, which actually issues that material to production. So, this again does not leave any room for human error or picking up the wrong material. So, it's it's a two-step a process. One is it creates an issue plan which gives advance intimation to stores in terms of what is required when, by which machine, at by which workstation. And secondly, automating that process of issuing the same, minimizing the human intervention, reducing the workload on them, and at the same time, reducing the possibility of any human error. Maintenance schedules. Each machine has its own schedule of a preventive maintenance. It is important that these schedules are captured and in an integrated solution. The production plans consider these schedules and do not load any work orders on those machines during the maintenance period. IcSoft MES not only publishes the schedule, so here we can see that which machine is having a maintenance schedule from which date to which date, but at the same time, what are the activities to be performed during those maintenances, and again having a checklist in terms of a confirmation whether all those planned maintenance tasks have been performed or not, again ensures that the plan does not just remain a plan, but it is executed uh, in a timely manner. Quality is another uh, important aspect of shop floor operations. So each part, based on the quality history, has its own planned tests, which could be a 100% test, which could be a sample test. And then the moment an order is scheduled, it is started. So we can see the operation here. And for this operation, the test which has been defined is a dimensional inspection. So the moment that operation starts, this pops up that this is the test to be performed for this particular operation. And under the dimensional test, which all dimensions have to be measured? What are the thresholds for those? What are the tolerances for that? Everything pops up there on the workstation itself, and either the quality inspector or the operator himself, depending on the nature. So here we are saying that the responsibility lies with production only. So we are not going to quality department for this test. The operator himself is taking measurements and reporting these values. So again, a plan is made for each part. The moment that part comes into production, the operation starts, all these tests pop up, and the operator is mandated to report the results. And unless the results are reported, like we said, there are built in controls that we cannot proceed ahead. We cannot go to the next operation unless we have completed the mandated quality tasks for the previous one. This again ensures 100% compliance and adherence to quality plans. Here we can see that against those various dimensional measures, a window pops up where the operator inputs the required values. This is another type of test where instead of the dimensions, it's a visual inspection whereby the operator says whether this is okay or not okay. Anything which is found okay is marked as okay, otherwise, it is marked as not okay. So, similarly, different types of tests and what is the expected uh, outcome, how much deviation is permitted, all this is built into the quality plan and then executed mandatorily during the operation performance. Machine control. Each machine on which various parts are made has certain parameters. So, for example, here we can see that this we are talking about an extrusion line here. So, it has got certain parameters like line speed, material pressure, then temperature, and then there are values of that which are reported. So, as long as those values are within the permissible limits, the machine continues to operate smoothly. Anytime when either through a sensor or through an HMI, a value is captured which is beyond the permissible limits, the machine automatically stops and it displays what is it that went out of control. So these kind of locks, these kind of machine controls are built into the process, which again, I mean, there could be workstations which are unmanned. So how do we ensure that those machines are performing exactly, they are in good condition to carry out production? So these type of machine controls ensure that machines do not operate under unfavorable uh, conditions. And this entire log of various readings taken over a period of time is available as a history for any analytics uh, at the end of the day or at the end of the shift. So now we come to the digital twin part of it. What all we get to see. Till now, we saw what kind of controls, what kind of inputs the MES is providing actually to the shop floor operations. Now we come to a section where the digital twin gives us the real time status of various aspects of the operation. So we start with the order status. So here we can see these are all work orders. All these work orders have got certain quantity and certain due dates. The first column, it tells us whether this order is on time or not. So here we can see someone has not taken action in time. So this entire column is red. This means all these orders are delayed. And how much is that delay? Here we can see the status as pending and we can also see the quantum of delay. As of now, all these orders are delayed by 53 days, which means they should have been completed 53 days earlier, but someone has not taken the action. This plan column tells us whether we have actually planned these orders. Now, when I say plan these orders, I mean whether we have assigned machines to those, whether we have assigned operators to those. We can see that those, though they are delayed, these are planned. And plan percentage is 100%, which means the quantity planned is equal to the required quantity. So there could be a possibility that the required quantity was 100, but due to capacity constraints or due to material constraints, maybe we planned only 80. In that case, we will see in this column less than 100, and we will also get a color mark here, some shade, which will tell us that these orders are under planned. This column tells us whether what is the uh, status of the actual production, whether production has started or not started, or whether the production is uh, completed or not completed. So here again, the production percentage is 100 here because we see that the required quantity was 256, the actual quantity is 256, so it's all green. But in rest of the cases, if the actual production is less than 80% of the required production, we see this color as black. If it is between 80 to 100, we see this color as orange. And if this is fully 100%, we see this color as green. So it's a very intuitive uh, kind of a dashboard, you can say, where just by looking at these color codes, the planner can decide which orders to focus on and what actions to take. Similarly, when it comes to machine status, so we saw in the previous example that we are measuring the temperature. So there could be a temperature sensor which is measuring the temperature. And here we see minimum and maximum ranges. So through the HMI screen, the operator is keying in the actual uh, temperature here. And in case the temperature reported is outside the limit, some kind of an alert or some kind of an alarm takes place, or it could be even a machine lock which could stop the machine altogether. Energy consumption. All the machines, especially the ones which are high energy guzzling machines, so for example, say furnace or uh, some high speed machines, monitoring the energy consumption of those serves dual purposes. One, wherever the energy consumption goes beyond the say some expected value, it's an alert that probably something is not well, maybe more friction is taking place, maybe some clogging is taking place, and we need to go and see why this particular or something is getting overheated. So we need to go and check whether you know something needs our attention. So that acts like an alert. And secondly, the uh, more uh, important part of this, I would say, is when to schedule a particular order, because many industrial areas have, they call it time based or use based tariff or time based tariff, where different days of the week or different times during the day have different energy tariffs. So once we are capturing the average energy consumption for a given part, we could schedule the high energy guzzling parts on those machines in such a way that they make use of those low energy tariff periods without really affecting the delivery performance. So that's the next level of intelligence which can be built on top of this energy consumption monitoring of the digital twin. Material availability. So having scheduled the orders, we need to know whether material is available for those or not, or rather the other way around, that we schedule only those orders where material is available. So this screen shows, so this is again the requirement status, what is the quantity needed, how much, what is the stock available, when it is needed. And similarly, the next screen shows whether there are any uh, shortages. Okay. And at the same time, it shows where the material is lying. So, for example, it's quite possible that though it is showing here as it's a shortage list, the shortage is being shown here, but maybe it is uh, lying in QC. Okay, so when we go to the QC tab, and we can check that whether something is lying in QC, whether something is lying in material inward section, to see whether it's a true shortage or not. And next one is, so previous one was material constraint, looking at the shortages. Next one is the capacity constraints. So here we can see that these orders which are loaded on these two machines is actually overloading the machines. The red sign shows that machines are getting overloaded. So what do? We take those two orders. So these two filling machines are actually overloaded, whereas there is a machine which is totally available, there is a machine which is partially available. So what does the system do in such case? How do we debottleneck that? Like we said, at the click of a button, the readjustment takes place and the orders are now split across those filling machines. So there is no overloading now. And you can see even the completion dates have been compacted now because the orders have been split on multiple parallel machines. So this is one of the most powerful features of a manufacturing execution system, because nothing exactly moves as per the plan, even if we are doing, say, finite capacity planning. So in real time, when things change and congestion takes place or overloading takes place, it's very critical to resolve these situations in least possible time, and that is exactly what this ABS is doing. Control charts. A process is under control if its variability is within the control limits. So these control limits, if we get into the statistical part of it, actually tell us whether these are normal variations or whether these are, some abnormal cause has induced these variations. So the moment the variability goes beyond the control limits, which we can see from the real time control charts, uh, we can investigate those reasons well in time before actually these variations start causing the damages in terms of faulty parts. So here we can see various machines and then their control charts. So as you can see, the IcSoft digital twin is your digital assistant on the shop floor, which assists you in two areas. One, in taking actions, actually, uh, you know, assisting you in operations in terms of scheduling the orders, in terms of issuing material requisitions, in terms of sending digital work instructions. So it's participating in the operations. And the second role the assistant plays is the digital twin aspect, which is the monitoring aspect, which is giving you the pulse of your operations in real time and which so it helps you to take real time decisions. For a detailed demo of IcSoft Digital Twin, please contact sales at itspl.com. Thank you.